Today we'll be reviewing the coordinate grid and writing linear equations. So let's start with a review of the coordinate grid. The coordinate grid has an x-axis, which is the horizontal axis right here, and it has the y-axis, which is the vertical axis right here. There are coordinates which show the location of a point on the graph. They always start with x and then y. So you have your x coordinate first and then your y coordinate second. If we look at the graph and we are given a point 3, -5, we have to locate where that point would be. First, start with the x coordinate, which is 3. 1, 2, 3. That would be right here. Then go to your y coordinate, -5. So count down from the origin, -1, -2, -3, -4, -5. That's right here. What we want to do is we want to see where this line, -5, and the positive line 3 would cross. That's about right here. And that is where we would draw our point. This point is at 3, -5. Then you have your quadrants. You have quadrant 1, which is in the upper right-hand corner. Quadrant 2 is located to the left of that. Quadrant 3 is the lower left-hand corner. And quadrant 4 is the lower right-hand corner. In quadrant 1, your coordinates are positive, positive. In quadrant 2, your coordinates are negative, positive. In quadrant 3, your coordinates are negative, negative. And in quadrant 4, your coordinates are positive, negative. And now we'll look at a review of intercepts. An intercept is where the graph crosses an axis. You can have an x-intercept, like B here, or you can have a y-intercept, like A here. Y-intercept is the one that we are most familiar with because it shows up in our slope-intercept form of the equation of a line. The intercepts are given at a point. An x-intercept will always be a number and then 0. The y-coordinate is always 0. So here, the x-intercept of this line is 6, 0. For a y-coordinate or a y-intercept, you always have a y-coordinate and the x-coordinate is 0. So you have a number for your y and your x is always 0. So for the point A, the y-intercept is -5, 0. So now we're going to look at writing linear equations. You need to use your notes or your paper that is given for your notes and a pen or pencil to get these notes down. The first thing we need to remember is that you have two equations that can help us. You have the slope-intercept form, which is y equals mx plus b. That is the equation of our line that we'll want all of our linear equations to be in. And then you have point-slope formula, which is y minus y1 equals m times x minus x1. You use this formula when you're given a slope and you're given a point, the x1 and the y1. So let's look at that first example. You're given a slope of 2 and a y-intercept of 15. Remember, our slope is m and our y-intercept is b. So all we have to do in this example is plug in y equals 2x plus 15. And that's the equation of our line. Let's go on to example 2. You have a slope of 1/2, recall that's our m, and a y-intercept of -7. Again, that's our b. So if we're going to plug it into the equation, y equals mx plus b, all we need to write is y equals 1/2 x minus 7. Let's look at our next example. Given a slope of negative 2/3 and it goes through the point 3, negative 6. This is where we're going to use the point slope formula. Again, the point slope formula is y minus y1 equals m times x minus x1. We are going to replace y1, m, and x1 with the information that we're given in the first example, or in this example. Our negative 2/3 is our m, which is our slope, and then our point x1 and y1 are 3, negative 6. So let's write the equation now with the information that we're given. Y minus a negative 6 minus a negative changes into addition, so y plus 6 is equal to our slope, which is negative 2/3 times x minus 3. We're going to take this negative 2/3 and we're going to distribute into the parentheses. So we have y plus 6 equals negative 2/3 times x, which is negative 2/3 x, and then negative 2/3 times negative 3. Well, we know that a negative times a negative is a positive, but now we need to look at the fraction. Negative 2/3 times negative 3. To make any whole number a fraction, we put it over 1. Then to multiply fractions together, we multiply straight across. We already said that a negative times a negative gives us a positive. Then we can just multiply numbers. 2 times 3 is 6. 3 times 1 is 3. 6 divided by 3 is 2. So it would be plus 2. Now there's one final step we have to do, and that is subtract 6. So the equation of our line is y equals negative 2/3 x minus 4. Another example, you have a slope of negative 3, that's our m, and an x-intercept of negative 3. That doesn't give us a point, but we know that the x-intercept is always the number for the x value and 0 for the y value. So our point is negative 3, 0. Remember, we're going to use the point slope formula, which is y minus y1 is equal to m times x minus x1. We're going to plug in what we know. Y minus y1, which is 0, is equal to our slope, which is negative 3, times x minus our x1, which is negative 3, so plus 3. Now we will distribute y, and we don't need to write minus 0 again. That's too redundant. So y equals negative 3 times x, which is negative 3x, and negative 3 times positive 3, which is a negative 9. So our equation is y equals negative 3x minus 9. Next, we're going to look at writing a linear equation given 2 points. The points we are given are 4, negative 3, which is x1, y1, and 3, negative 6, x2, y2. From what we've looked at earlier, you have to have a point and a slope to be able to write an equation. What we did on Friday is we took 2 points and found a slope, so we can do that today. Remember, your slope equation is y2 minus y1 over x2 minus x1. So we're going to take the information that we know and plug that in. y2 is negative 6 minus a negative 3, so that changes to plus. And then we have 3 minus 4. Negative 6 plus 3 is negative 3, and 3 minus 4 is negative 1. So our slope equals a negative 3 over negative 1, or that can be rewritten as positive 3. So now we have an m, we have an x1, and we have a y1. So we need to plug it in to our point-slope formula. Y minus y1 is equal to m times x minus x1. We plug in what we know. We know the y1, the slope, and the x1. So we have y minus a negative 3, so plus 3, equals our slope, which is 3, times x minus 4. Now we take the 3 and we distribute. Y plus 3 is equal to 3x minus 12. We can subtract 3 from both sides. So we'll have our equation. Y is equal to 3x minus 15. Let's do another example just like that one. First, we have to find the slope. x1, y1, x2, y2. Remember to find slope. We take y2, which is 7, and subtract y1, which is negative 5, so we're going to add 5, over x2, which is 5, minus a negative 5, so that changes to plus 5. 7 plus 5 is 12. 5 plus 5 is 10. 12 over 10 is the same as 6 over 5. Now we'll plug it in to our point-slope formula. Y minus y1 is equal to m times x minus x1. Y minus a negative 5, so minus a negative changes to plus, so plus 5, equals our slope, which is 6 over 5, times x minus a negative 5 again, so plus 5. We distribute the 6 over 5, so we have y plus 5 is equal to 6/5 x, and then we're going to multiply that 6/5 times 5 over 1. If you multiply straight across, you get 30 over 5. 30 over 5 is equal to 6. So at the end of this equation, it should be plus 6. Our last step, subtract 5 from each side. Y is equal to 6/5 x plus 1. Now we're given an equation that gives us a y-intercept, negative 3, and an x-intercept of 7. We need to write out what those points would be. We know that the y-intercept always has a 0 as its x value, and the negative 3 is the y value. The x-intercept is always the x value, and then your y is always 0. So for this equation, we need to find the slope. x1, y1, x2, y2. So do 0 minus a negative 3, so plus 3, because remember minus a negative changes to plus, and then 7 minus 0. 0 plus 3 is 3. 7 minus 0 is 7. Think back to the very first example we did. Y equals mx plus b, where m is our slope and b is our y-intercept. We have the y-intercept right here. So we don't need to go ahead and do the point slope formula and then solve. All we have to do is plug in the 3 over 7 into your m, and then the negative 3 into the b. So the equation of that line is y equals 3/7 x minus 3. Two more examples left. The first one says a horizontal line that goes through the point -2, 6. First, we need to find the point -2, 6. We locate -2 on the x-axis, which is right here, and I locate 6 on the y-axis, which is right here, and find where those two lines cross. Now I'm going to draw a horizontal line. A horizontal line, remember, looks like the horizon. It's flat and runs side to side. I want to know the equation of that line. If I picked any other point on that line, my y value would never change. So if the y value never changes, our equation is y equals that y value. The y value here is 6. So y equals 6. The last example is the vertical line that goes through point 5, -3. Again, we need to locate 5 on the x-axis, which would be right here, and -3 on the y-axis, which is right here, and see where those cross. 5, -3, the point would be right here. If we have a vertical line, that's like you're standing tall, so you have a line that goes up and down. If you picked any point on that line, you would notice that the x value never changes. So if the x value never changes, your equation is going to be x equals, and then whatever that x value is. Here it is 5. So our equation of the vertical line that goes through the point 5, -3 is x equals 5. Now you have an assignment left to do for your classwork. If you don't finish, it is homework. Good luck. If you have questions, please raise your hand.